Hey everybody, in this video clip, I'm going to demonstrate how to use a replacement tool to facilitate combining input levels of a categorical input. So when we say combining input levels, we consider a case in which there are excessive number of input levels, such as zip code. There are 42,000 distinct input levels. So allowing for that many dummy variables would lead us to a complete model overfitting. So to avoid that, what we do is we combine excessive input levels of a categorical input into smaller number of sort of levels. So let's see how it works. So to do that, I'm going to bring in a replacement node from Modify tab. So replacement is here, and I'm going to insert this between transform and impute. So before I do any imputation, I'm going to do this sort of replacement task. So I'm going to delete this and connect transform variable to replacement and replacement to impute. And since we're going to make changes, we're going to do replacement only on a certain categorical inputs. If you select replacement, we are not going to do any replacement when an input is categorical or enable. So you have to actually nullify this option by selecting none. So we're not going to anything on enable variables, but only on categorical inputs. So within class variables property group, select replacement editor. Then the replacement editor will appear. Take some time. So when it appears, right, so this displays the entire categorical inputs existing in the data set. Obviously, there are many different distinct input levels and DEM cluster variable. So you can certainly collapse some of these values into one. That's something you can certainly do. But for the sake of this demonstration, we're gonna collapse combining this distinct values in status category 96 NK. This particular variable indicates whether a customer is active or first timer or inactive. So the formatted value A, it actually means active. S, star donors. So A, active, star basically indicate the same thing. They are very live. They are active donors. So we're going to group them into one by assigning the same letter value A here and A there. So we group these two into one, since now they take the same value. F, first time, N, new donors, so they actually the same thing, enter the same value. Let's say F here, F there. E, indicating inactive. L, lapsing, so inactive, lapsing donors, same thing. So I'm gonna assign the same letter value E here and E there. So by doing so, we have the number of distinct values from 6 to 3. And see what impact it has on the resultant logistic regression results. All right, so let us run this replacement node since we haven't run it yet. So run this. Okay. Yeah, so it started from the first node and then moves on, and now it's running on replacement node. Okay, so this was the input we selected to perform replacement, and this is the mapping method. So we combine formatted value A and S into A, and F and N, F, E and L to E. So the changes have been made, and with these changes being made, as you can expect, we're going to rerun the logistic regression with same set of chosen model selection method and selection criterion. And when it completes running the model, I'm going to look for whether the replaced status category 96 NK input ever appears in the select list of inputs. If so, then basically the second replacement node play a important role in improving the model performance. It's finally running logistic regression. Okay, finally, it's done. So select results. I'm going to look at the iteration plot first. View, model iteration plot, and what seems that it didn't affect, it hasn't changed the optimal level of complexity. I mean, it still remains as 4. That's interesting. And I maximize the output window and scroll all the way to the end. I'm going to jump to the line 3659, 3659. Right, here's the summary of selection, stepwise selection. So before, although we saw the optimal level of complexity is determined to be 4, this is how it sort of evaluated even a larger in a sequence of models. And the question that we had earlier is whether the second replacement node played any significant role. And as you see from the step 19, sorry, not 19, let's look for, actually step 6, the status category 96NK with the REP replaced prefix. This one entered at step 6, so it did impact on the result. Although the optimal level didn't change at all, but we can see how that affected the subsequent analysis. All right, so let me stop here. Okay, let me stop.